All right, welcome to the third installment of the Chapter 6. This is Section 6.3, Part 1. This is going to be a two-part section because there's a lot in it, and I don't want you to get too confused right off the bat. So there are three what you will learn. However, we're only going to do one. We're going to define and evaluate logs, and we're going to figure out what this word logs mean. You may see this on the SAT test, so this is pretty important. So let's get this straight. All right, so it says, you know that, and I hope you know, okay, that 2 squared is equal to 4. That makes sense. 2 times 2 is 4. And 2 cubed is 8, because 2 times 2 is 4. 4 times 2 is 8. Okay, but what about 2 raised to what number is equal to 6? Well, if 2 squared is 4 and 2 cubed is 8, this x has to be somewhere between 2 and 3. I hope that you would agree with that. So really, we don't have really any idea. There's no way we can do this using our head. So they came up with a long time ago. Famous mathematicians came up with this idea of logarithms, and they came up with an equation to figure this out. Okay, and this will make literally no sense. Oops. Let me get rid of that. It should be an x. I should have put a 6 there. This really will make no sense to you until we see what the definition means. But this simple little equation will actually be able to tell us 2 raised to what power will equal 6, because really we have no way of knowing that as of this point. Okay, so let's look at the definition of a log and what the definition tells us. The definition of a log is, and it's a very strange definition because they're not words and sentences. It says log base b, so that's how you say this, log base b of y is equal to x, if and only if b raised to the x power is equal to y. And the b, the y, and the x are the same in both of these. And these go back and forth. That's what this double-headed arrow means. You can go from the left to right or right to left. Okay. So for instance, okay, let's see if we can come up with an example of this working. So log base 2 of 3 should equal 8. Oops. I am making too many mistakes here, so I'm going to switch this around. Log base 2 of 8 equals 3. Okay, there's log form. Okay, so this side right here is called log form. And on the right is called exponential form. Exponential form. And you can go back and forth from one form to the other. So here's log form. Log base 2 of 8 equals 3. That is a true statement for a log, and we're going to see why. So to write it in exponential form, okay, you take your base of your log, you raise it to what's after the equal sign. So 2 raised to the third power is equal to the bigger number that's next to log. So not bigger as in it's a greater number. It's just the bigger one between the base and the number next to log. So, and hopefully that's a true statement. Is 2 raised to the third power equal to 8? I do believe it is. I do believe it is. Okay, so going back to the last page, still to this point, we still don't have a method of figuring out this answer. But later on in this section in the chapter, we will get some information to be able to do this particular problem. Okay, but let's focus on this one, going from log form to exponential form and vice versa. We should be able to go back and forth. Okay, so once again, it's the base b raised to what's after the equal sign, and it's equal to the bigger of the two next to it. So b to the x equals y. Okay, so let's look at example number 1. It says put the log form into exponential and the exponential form into log. All right, so on the left here we have a bunch of problems that are in log form. Okay, and we're going to put these into exponential. So 2 raised to what's after the equal sign is equal to the number next to log, which is 16. We want to make sure that's true. Is 2 to the 4th 16? I do believe that is true. Okay, next one. 4 raised to what's after the equal sign is equal to the number next to it. So 1 is 4 to the 0 equals 1. Yes, it is. Okay, moving along, and I chose these because these are some of the more common logs that you'll see. 12 raised to its after the equal sign is equal to the number next to the log, which happens to be 12 as well. Is 12 to the first equal to 12? Once again, I do believe it's true. Okay, a little harder one here. The base 1/4 in parentheses raised to what's after the equal sign, so -1, is that equal to the number next to the log, which is 4. All right, so I guess we're going to have to, let's test this one out and see if that is true. So I'm going to distribute this -1 to everything. Actually, I'm just going to drop to the bottom and make it positive. So 1/1/4 raised to the +1. But do I really need that +1 there? No, that doesn't make any much sense. I don't need that. Okay. Now, how do I divide fractions? I multiply by the reciprocal. So 1, get back to the pen. So 1 times the reciprocal of 1/4 is 4/1. What's 1 times 4? That works. It's the answer is 4. Okay. So that one is fairly tricky. All right. Now let's go the opposite way. Now we're going to go from exponential form. So this is exponential form, and we're going to go to log form. Okay, so all of these need to have a log. The base of the exponent is the base of your log. Okay, the number next to the equal sign on the right is the number that goes next to the log, and after the equal sign is your exponent. So 5 raised to the second power is equal to 25. Okay, that should hopefully make some sense. All right, let's do the next one. Same thing. I need a log in my answer. The base of the exponent is 10. The number after the equal sign goes next to my log, and that number, the exponent, goes to the right of the equal sign. Okay, and that should make sense as well. 10 to the -1 is 1/10 to the +1. All right, so next one, 8 to the 2/3 equals 4. So log, the base of my exponent is 8. That's the base of my log. The number after the equal sign is the number that goes next to my log, and after the equal sign is the exponent, so 2/3. Okay, and if you type this in on your calculator, 8 to the 2/3, it would be equal to 4. And last but not least on this page, log first. The base of my exponent is the base of my log. The number after the equal sign goes next to my log, and the number that's the exponent goes to the right of the equal sign. So 6 to the -3rd is 1/16, or 1/6 to the +3rd. So 6 to the +3rd is 2/16. That's where that comes from. Okay, so that's general going back and forth from one to the other using the definition of a log. Okay, using this information. All right, let's see what we got next. Okay, and example 2 now says to evaluate logs. Okay, so what we're going to do is we're going to evaluate these numbers. So notice that there's nothing after the equal signs in any of these. So I'm going to put an X after every one of these, because that's what we're trying to figure out. We want to figure out what these are equal to. Okay, so all I'm going to do is, if we don't know what the answer is, we're going to set up the definition. So the base, so 4 raised to what's after the equal sign, which is X, is equal to the big number next to it, so 64. Okay, so what number, let me make that a little neater. Let me erase it and make it neater. All right, so it should say 4 raised to the X is equal to 64. Okay, so what number am I raising 4 to get 64? And hopefully you can see that it would be 3. 4 times 4 is 16. 16 times 4 is 64. So my answer is X equal to 3. Okay, let's look at the next one. All right, this one's a little bit harder. So 5 raised to what's after the equal sign. So 5 raised to the X is equal to, and let me move this out of the way, that actually says 0.2. So 5 raised to what number is equal to 0.2? 0.2 is 2/10, right? Which is really equal to 1/5. So 0.2 is 2/10. 2/10 is really 1/5. So I'm going to get rid of this 2/10 here and the 1/5. And it really should just say 5 to the X is equal to 1/5. Now that's a little bit easier to look at now. So how do I turn a whole number, 5, into a fraction 1/5? Well, I'm going to raise it to -1. So 5 to the -1 is equal to 1/5. How do I get rid of fractions? You drop it to the bottom of A underneath the 1. So -1 would be my answer there. Okay, so turning a whole number into a fraction, you have to have a negative exponent. All right? All right, so let's see here. We are going to now do this one. So 1/5 raised to the number after, so 1/5 in parentheses raised to the x is equal to 125. Now this is very similar to the last one we did. The last one we turned a whole number into a fraction. Now we want to turn a fraction into a whole number. So once again, we're going to need a negative exponent. So 1/5 raised to the negative what is equal to 125. So to bring this to the top, so what number do I raise 5 to get 125? So 5 times 5 is 25. 25 times another 5 is 125. So the answer would be -3. So x equals -3. So once again, let's recap. To turn a whole number into a fraction, we use negative exponents. And to turn a fraction into a whole number, we also have to use negative exponents because we are flip-flopping. If it's going from the bottom to the top or the top to the bottom, we have to use negative exponents. Okay. And these are tougher examples, and I'm giving you some of the tougher ones so we can get these out of the way and you'll know how to do them. Okay. So last one here, part D, it says 36 raised to what's after the equal sign is equal to x, and it should be equal to the number next to log, which is 6. Okay, so now once again, here's another pretty tough one. How do I get a big number 36 equal to a smaller number? Okay, and I think you learned this in Algebra 2A, but we're going to use some fractions. Fractions will help us do this. And if we recall, remember the square root of 36 is equal to 6. Okay, and I'm just recalling that from some mental math here. I'm kind of saying, well, how do I get 36 into 6? Well, I know that if I take the square root of it, I should be able to get 6. All right, so make this page a little bigger here. And now we have to recap from Algebra 2A, what exponent are square roots? Okay, what exponents are square roots? And hopefully you remember that fractional exponents are square roots. So 36 to the 1/2 is equal to 6. So x is equal to 1/2. To get a bigger number down to a smaller number, we're usually going to use fractional exponents. Okay, so don't forget that. Make a note of that. All right, so that's example 2, and those are some pretty tough examples. So hopefully you can catch on, but we'll work on those tomorrow. And last but not least, in this part part 1 is there are 3 different types of logs. The logs we've talked about on the previous pages have had different bases, 2, 3, 5, 1/5, whatever. But there are two logs that have names. Okay, the first one's called common logs. The second one's called natural logs. Common logs are base 10. Okay, so if you see base 10, but it won't say base 10, usually it will just leave it blank. So if you see a log with nothing as the base, you know that it's going to be a base 10 because they leave it blank. So common logs are just log of x. So for example, if you see something like this, that means log base 10 of 8. They just leave it blank. Okay. Secondly, we have something called natural logs. And natural logs, remember natural base, we use e's. So natural logs are log base e of x, but we don't write it that way. The calculator has a button that actually does this for us. It's called ln. It's the ln button. So ln meaning natural log. Okay, so we would write log base e of x as ln of x. Okay, and the nice things about common logs and natural logs is that we can use the calculator. Okay, they're very simple. So we have example 3 here. It says evaluate these common logs and natural logs. Okay, so let's set them up and then we're gonna solve them. So remember, when there's no base, we're assuming it's 10. So I'm going to say equals x because we don't know what any of these are equal to. So remember, we're assuming this is a 10, so I'll just write it in. So 10 raised to the x power is equal to 8. Okay? Well, I don't believe I know the answer to that in my head, so we're going to use the calculator to do this type of problem. Okay? So let's see here. So it's log base 10 of 8. If you notice on the left-hand side here, there's a log button. Calculators do log base 10. So if I just type in log of 8 like the original problem said, I hit enter, it'll give me an answer of 0.9. So that's my answer. Yeah, x equals 0.9. Now, how could I check that? I can go right back to the calculator, and if I look what it says 10 raised to the x is 8. Well, x is equal to 0.9. What's 10 raised to the 0.9? And there we go. 7.9 rounds to 8. Okay, so there's my correct answer. All right, so let's look at the second one. This one says ln of 0.3 is equal to x. Okay, what does that really mean? Remember, ln means log base e. So e raised to the x is equal to 0.3. Well, I really have no idea how to do that one in my head, so I'm going to use the calculator to do this one as well. All right, so what does it say? It says e raised to the x. Well, once again, notice there's log and ln right above each other, okay, on this left-hand side here. So now I'm going to do ln of 0.3, close my parentheses, hit enter, and there is my number. So remember, how do I turn something into a fraction? Well, I'm going to have to use a negative, so negative 1.2. So x is equal to negative 1.2. Okay, I'm going to check my work, make sure that's correct. So we'll bring it over here. E raised to the x, well, my x is negative 1.2. So second ln, negative 1.2, close my parentheses, and it should equal 0.3. And there we go, 0.3011, so 0.3. So it worked. Okay, so now logs are very difficult. They're confusing. They're different than we're used to. That's why I'm only going to keep this as a short one. Hopefully this makes a little sense. We'll definitely work on this tomorrow in class, and I will see you tomorrow.